Welcome to another episode of My Weird Prompts, an AI-generated podcast featuring the random prompts of Daniel Rosehill as answered by a revolving cast of friendly AI characters. Join us for deep dives into AI, technology, and whatever other random thing Daniel finds fascinating today. Subscribe on Spotify or your favorite podcatcher. Now, today's episode.
My Weird Prompts is an AI-generated podcast produced by Daniel Rosehill, a verified human with documentation to prove it. While every effort is made to ensure our AI hosts draw from credible sources and run on cutting-edge models, they do occasionally make things up with alarming confidence. As with everything in life, and especially this podcast, treat all claims as spurious until confirmed to be not. Daniel, Herman and Corn accept no responsibility for any decisions made based on the confident ramblings of our artificial presenters. Now, today's episode.
Hello again to Corn the Sloth and Herman the Donkey, my two favorite virtual AI bots hosting this podcast. And continuing with the generative AI theme of our latest episodes, I'd like to ask you two a question about two very big areas if you're getting into local AI, you're going to either have an NVIDIA GPU or an AMD GPU, to the best of my knowledge. I don't know if there's other minority manufacturers, but almost everyone has one or the other. And when you are doing things with your GPU on a computer, especially with AI, you're going to come across two names. CUDA, I'm not sure if that's pronounced correctly, in case not, CUDA for NVIDIA. And on AMD, we have ROCm. Now, what I'd like to ask you guys is that in addition to having the GPU drivers installed on my computer, in order to get things to work, for example, the rendering process I'm running as I record this on my to render out video, there is ROCm, there is driver, and all that's needed to work in harmony. And when you're getting involved with stuff like PyTorch, you have to build PyTorch to play nice with ROCm to get things to work. So here's my question. CUDA and ROCm in simple terms. What are these? Explain exactly how this stack fits together between the GPU and your machine, the driver to interact with the GPU, and then this additional framework that we need in order to make AI inference happen on the local environment. It's a very big deal in the sense that these are integral components, but I'd love to get some clarity into exactly what they do and the evolution of ROCm in particular. I probably will move over to NVIDIA as soon as I can afford a really nice NVIDIA GPU. But for the moment, I'm in AMD land. And therefore, I'm interested to know about sort of the support picture for ROCm and AMD. I know that it's improving. I know that there's some very serious industry partners working on better support for it across the board. So what does that look like? Clearly, there is a lot at stake here in terms of the dominance of one GPU type over the other in the global AI industry. So what are ROCm and what is AMD doing to try to assert some kind of market share and have a future whereby everything is not running on NVIDIA?
Welcome back to My Weird Prompts, the podcast where Daniel Rosehill sends us the most intriguing ideas, and Herman and I try to make sense of them. I'm Corn, your endlessly curious guide, and with me, as always, is the exceptionally insightful Herman.
And I'm Herman, ready to dive deep into the technical trenches. This week, Daniel has sent us a fascinating and, frankly, highly relevant prompt that sits right at the heart of modern AI development, especially for those venturing into local AI.
He really did. Daniel wanted us to explore the world of CUDA and ROCm. He specifically asked about what these are in simple terms, how they fit into the entire AI stack from the GPU to the framework, and what the deal is with AMD's ROCm and its evolving support picture. He even mentioned he might move to NVIDIA if he can get a nice GPU, but for now, he's firmly in AMD land.
Absolutely. And what's interesting, Corn, is that this isn't just about different brands of hardware. This topic touches upon the very foundation of how we make our machines think with AI. It's about the underlying software platforms that enable GPUs to perform the complex parallel computations required for AI inference and training. What most people don't realize is that without these foundational layers, even the most powerful GPU is just a really expensive paperweight when it comes to serious AI work. The stakes here are quite high, shaping the future dominance in the global AI industry.
Okay, so it's not just about raw computing power, it's about the software that unlocks it. That's a huge distinction. So let's start at the beginning. Daniel asked us to define CUDA and ROCm. Herman, for someone like me who just wants my AI model to run, what exactly are these things?
Great question, Corn. Let's break it down. Think of your graphics processing unit, or GPU, as a super specialized calculator. It's incredibly good at doing many simple calculations all at once in parallel, which is exactly what AI models need. Now, to tell that calculator what to do, you need a language, a set of instructions. CUDA, which stands for Compute Unified Device Architecture, is NVIDIA's proprietary parallel computing platform and programming model. It's essentially a software layer that allows developers to use NVIDIA GPUs for general-purpose computing, not just graphics. It includes a software development kit, or SDK, which has libraries, compilers, and a runtime environment. When you hear about an AI model running on CUDA, it means it's leveraging NVIDIA's software stack to make its GPU do the heavy lifting.
So, CUDA is like the operating system for an NVIDIA GPU when it's doing AI tasks. It's the brains telling the brawn what to do.
That's a very good analogy, Corn. It provides the framework for software to efficiently communicate with the GPU hardware. It handles everything from managing memory on the GPU to orchestrating how thousands of small computations are run simultaneously.
Got it. And then there's ROCm, which Daniel also brought up. Is that just AMD's version of CUDA?
Precisely. ROCm, or Radeon Open Compute Platform, is AMD's answer to CUDA. It's also a software platform designed to enable high-performance computing and AI on AMD GPUs. The key difference, as its name implies, is that ROCm is largely open source. It provides a similar suite of tools, libraries, and compilers, allowing developers to harness the parallel processing power of AMD's Radeon GPUs.
So, it's AMD saying, hey, we can do that too, and we're going to do it in an open way. But why do we even need these frameworks? Couldn't the AI frameworks, like PyTorch or TensorFlow, just talk directly to the GPU drivers? Daniel mentioned needing a driver on this additional framework.
That's where the stack Daniel mentioned comes into play, and it's a crucial point. You see, the GPU driver is the lowest level piece of software. It's essentially the interpreter between your operating system and the physical GPU hardware. It handles very basic tasks, turning the GPU on, sending raw data, managing power states. But for complex tasks like AI, you need more than just raw data transfer. You need to organize computations, manage large chunks of memory, and ensure that different parts of your AI model run efficiently on the GPU's many cores. This is where CUDA or ROCm step in. They sit above the driver.
Okay, so GPU is the hardware, the driver is like the basic translator, and then CUDA or ROCm is the sophisticated interpreter that understands AI-specific commands.
Exactly. These platforms provide a higher level abstraction. They offer APIs, application programming interfaces, that AI frameworks like PyTorch or TensorFlow can call upon. Instead of PyTorch having to know the nitty-gritty details of how to make an NVIDIA GPU perform a matrix multiplication, it can just say, hey CUDA, run this matrix multiplication for me, and CUDA handles the complex interaction with the driver and the GPU hardware, optimizing it for the driver and the GPU hardware, optimizing it for the specific architecture. And Daniel's experience with building PyTorch to play nice with ROCm highlights this perfectly. For PyTorch to use ROCm, it needs to be compiled or configured to understand and utilize ROCm's specific APIs and libraries. It's not always an out-of-the-box, seamless experience, especially with a newer, less dominant platform like ROCm compared to the mature CUDA ecosystem.
That makes so much sense. So it's a multi-layered ecosystem, and each layer builds upon the last, providing more specialized functionality. The AI frameworks are at the top, telling CUDA or ROCm what to do, which then tells the driver, which then tells the GPU.
Precisely. And this stack ensures efficiency. CUDA, in particular, has been refined over decades to squeeze every bit of performance out of NVIDIA GPUs for parallel computing workloads. This includes highly optimized libraries for linear algebra, deep learning primitives, and various scientific computing tasks. It's the reason why NVIDIA has such a strong hold in the AI market.
That's fascinating. But Daniel also asked about the evolution of ROCm and what AMD is doing. If CUDA is so dominant and mature, what chance does ROCm really have?
It's a classic underdog story, Corn, but with some serious muscle behind the underdog. NVIDIA has had a significant head start. CUDA was introduced in 2006, giving it nearly 2 decades to build an incredibly robust ecosystem, with extensive documentation, a massive developer community, and integration into virtually every major AI framework and research project. This network effect is incredibly powerful. More developers use CUDA, leading to more tools, better support, and round it goes. ROCm, on the other hand, arrived much later, around 2016. For a long time, it struggled with compatibility, performance parity, and a much smaller developer community. Developers often found it difficult to port CUDA code to ROCm, or even to get their AI frameworks to work smoothly with AMD GPUs.
So, for a while, if you were serious about AI, you almost had it to go NVIDIA. That explains why Daniel might consider moving over.
Exactly. NVIDIA's dominance, especially in data centers and high-end AI research, is undeniable, holding well over 90% of the market for AI accelerators. But here's where AMD's strategy and ROCm's evolution become critical. AMD recognized this gap and has been heavily investing in ROCm. Firstly, by making ROCm open source, they're hoping to attract developers who prefer open ecosystems and want more control. This also encourages community contributions, which can accelerate development. Secondly, they focused on improving direct compatibility layers, making it easier for CUDA applications to run on ROCm with minimal code changes. This is huge because it lowers the barrier for switching.
So, they're not just trying to build their own ecosystem, but trying to be compatible with NVIDIA's. That's a smart move.
Absolutely. They've also been improving their hardware with their Instinct MI series GPUs specifically designed for AI and HPC workloads, offering competitive performance, and they're building partnerships. Daniel mentioned serious industry partners working on better support. This is key. Companies like Meta, for instance, have been collaborating with AMD to ensure better PyTorch support for ROCm, for example, which is a significant endorsement and helps build out the ecosystem. This concerted effort aims to chip away at NVIDIA's market share by offering a viable, open-source alternative that provides strong performance, especially at certain price points or for specific enterprise applications. They're trying to create a future where everything is not running on NVIDIA, as Daniel put it.
That's a huge undertaking, trying to break that NVIDIA stronghold. So, if AMD is pushing ROCm and improving its hardware, what does that support picture look like right now for someone like Daniel who is in AMD land? What can he expect?
The support picture for ROCm on AMD has significantly improved, though it's still playing catch-up to CUDA's maturity. For developers, this means better documentation, more robust libraries like the ROCm port of MIOpen for deep learning, and increasingly streamlined integration with major AI frameworks. For example, recent versions of PyTorch and TensorFlow have much better native support for ROCm, often requiring fewer manual compilation steps than in the past. There's also been a greater focus on ensuring stable releases and broader hardware compatibility within AMD's own GPU lineup, moving beyond just their high-end data center cards to sometimes include consumer-grade GPUs, although this varies and is often more experimental. The community around ROCm is growing, leading to more shared solutions and troubleshooting guides.
Okay, so it's getting better, but still maybe not as plug-and-play as NVIDIA?
Not quite as universally plug-and-play as NVIDIA with CUDA, which has had a much longer time to iron out kinks and integrate everywhere. With ROCm, you might still encounter scenarios where specific models or exotic framework configurations require a bit more manual tweaking, or where performance optimizations aren't as mature as their CUDA counterparts. However, for many common AI tasks and models, especially those supported by mainstream frameworks, ROCm is becoming a very capable platform. AMD is clearly committed to making ROCm a compelling choice, leveraging the open source ethos to foster innovation and community engagement.
That's super insightful, Herman. So, for our listeners, what are the practical takeaways here? If someone is looking to get into local AI, or even just understand the ecosystem better, what should they keep in mind regarding CUDA and ROCm?
Excellent question, Corn. For those diving into local AI, the choice between NVIDIA and AMD GPUs, and by extension CUDA and ROCm, comes down to several factors. First, ecosystem maturity and ease of use. NVIDIA, with CUDA, generally offers a more mature, robust, and often easier to use experience, especially for beginners. The sheer volume of online tutorials, pre-trained models, and community support built around CUDA is immense. If your priority is to get things up and running with minimal hassle and broadest compatibility, NVIDIA has a distinct advantage.
So, if I just want to install something and have it work, NVIDIA might be the path of least resistance.
Generally, yes. Second, open source versus proprietary. If you value open source principles, want greater transparency, or are interested in contributing to the underlying software, ROCm is AMD's open source offering. This can be appealing for researchers or developers who want to tinker deeper with the stack. It also prevents vendor lock-in, which is a significant consideration for large organizations.
That makes sense. It's like choosing between a walled garden with all the amenities or an open field where you can build your own.
A good analogy. Third, hardware availability and price. Performance. While NVIDIA dominates the high-end AI accelerator market, AMD often offers competitive price-to-performance ratios in certain segments, especially for consumer-grade GPUs that can still handle substantial AI workloads locally. If budget is a primary concern, or if you already own an AMD card, understanding and utilizing ROCm effectively can unlock significant AI capabilities without a new hardware investment. Daniel's situation is a perfect example of this. Fourth, future-proofing and industry trends. The AI landscape is evolving rapidly. While NVIDIA has a commanding lead, AMD's continued investment in ROCm and its push for an open ecosystem could lead to a more diversified market in the future. Keeping an eye on developments in ROCm support from major AI frameworks and cloud providers is important. A more competitive landscape ultimately benefits everyone by driving innovation and potentially lowering costs.
So, it's not a simple choice. It's about weighing your priorities, your existing hardware, and your comfort level with potentially more hands-on configuration. It's really about understanding what you're getting into.
Exactly. And to add a slightly different perspective, for the global AI industry, the competition between CUDA and ROCm is vital. A dominant monopoly can stifle innovation and lead to higher costs. AMD's persistent efforts with ROCm ensure there's an alternative, fostering a healthier, more competitive environment for AI development worldwide. It pushes both companies to innovate faster and offer better solutions.
That's a crucial point, Herman. The competition drives progress, which is good for everyone. So looking ahead, what's next for CUDA and ROCm? Do you see ROCm truly catching up, or will NVIDIA maintain its stranglehold?
That's the million-dollar question, Corm. I believe NVIDIA will retain its market leadership for the foreseeable future, especially in the most demanding data center AI workloads. Their ecosystem is just too entrenched and mature. However, ROCm's trajectory suggests it will become a much stronger and more viable alternative. We'll likely see it gain significant traction in specific niches, perhaps in academic research where open source is highly valued, or within companies leveraging AMD's full hardware stack for cost-effectiveness. The future of AI relies heavily on accessible compute power. If AMD can continue to lower the barrier to entry with ROCm, offering compelling performance and ease of use, they absolutely can carve out a substantial, lasting market share. The open source model has the potential for explosive growth if it reaches a critical mass of developers. It's an exciting time to watch this space.
It certainly is. This has been a super deep dive into a really critical topic for anyone interested in the nuts and bolts of AI. Herman, thank you for breaking down such complex concepts into understandable terms.
My pleasure, Corn. It's a field that's always evolving, and these underlying platforms are fundamental to that evolution.
And a huge thank you to Daniel Rosehill for sending us such a thought-provoking prompt about CUDA and ROCm. We love exploring these weird and wonderful technical challenges he throws our way.
Indeed, Daniel's prompts consistently push us to explore the most interesting and impactful aspects of human, AI collaboration, and technology.
If you want to dive deeper into these topics or have your own weird prompt you'd like us to explore, make sure to find My Weird Prompts on Spotify and wherever else you get your podcasts. We'll be back next time with another fascinating prompt from Daniel.
Until then, keep exploring and keep questioning.
Goodbye for now.
Farewell.
Thanks for listening to another episode of My Weird Prompts, an AI-generated podcast featuring Daniel Rosehill's AI prompts, as answered by a revolving cast of friendly AI characters including me, Cornelius the Sloth. Subscribe on Spotify or visit myweirdprompts.com.